There's a visual tool which will help us put across all the possibilities with a logical manner, and that is your tree diagram. So the funda over here is a tree diagram or a visual representation of the possible outcomes of a sequence of events. Okay, each branch of this tree represents a possible outcome, and the end point of each branch represents a final outcome. What does that mean? I'll explain it with an example. So we have a kid who has to choose a square and place a triangle in it. So it has to make a pattern. So we have 3 squares. So we give 3 squares and 2 triangles, right? So what all pattern the kid can do, we can represent with the help of a tree diagram. So I can explain it this way. We have this to be the starting of the time. So as the time passes, the kid would have chosen either yellow, green or purple, right? If it chooses yellow, in time it has the possibility of choosing this triangle or this triangle, resulting in an yellow square or a red triangle pattern, or a yellow square and a blue triangle in it. So that's the pattern it chooses if it goes like this or like this. So if you further continue, there are different possibilities, right? Each of this branch talks about different possibilities. That's what we're looking at. Okay, so let's put this on a paper. So what is that we have to keep in mind? Label each branch. We have to label. Here I happen to represent with colors and all of that. Of course, it's not possible on a sheet of paper. It's not practical, not more than possible. For each branch, add a probability or frequency of a particular outcome. So this we'll understand. Again, this topic is used in probability as well. So it's pretty important. Guys, probability is one of the hardest. Yes, trigonometry feels to be hard as of now. It might feel to be so, but I can promise you probability is tougher. Okay, same scenario. I'm going to put it across using this particular diagram. So this would represent square 1, square 2 and square 3. Next, the kid can choose triangle 1 or triangle 2. So we can either write it horizontally or vertically. So as you can see, I'm choosing horizontally. So each of these branches represent choosing of triangle 1 or triangle 2, triangle 1 or triangle 2, triangle 1 or triangle 2. Okay, so let me make them, yeah, that would be better. So finally, I'll write this. I can choose a square 1 and a triangle 1. Not me, the kid can choose a square 1 and a triangle 1, square 1 and triangle 2, square 2 and triangle 1, square 2 and triangle 2, square 3 and triangle 1, square 3 and triangle 2. So these are all the possible outcomes. That's what we have written over there, right? So finally, we'll be looking at all the possible outcomes. Is it, guys? So are we looking at it? Yes, we are, right? So that's how you represent a particular scenario. Same thing over here. Say I have a rectangle 1, and so I have set of rectangles, say 3 set of it, and I have 2 triangles. So we saw this particular example, right? How can we represent this example? So same diagram, just that I'm going to use R1, R2 and R3. So R1, R2 and R3, and this will change to, instead of S1, S2 and all of that, it would be R1, T1, R1, T2, R3, T2, so on and so forth. Okay. Now, finally, we have one last scenario to show that, it's not easy to, wrong thing. It's not easy to do this all the time, right? But yeah, we can do it with any number of things, but it's not practical. So let's have a look. What is that we're looking at? We have Subnam. She has 2 boxes, 3 tiffin and 2 water bottle. In how many ways can she carry the item? Only one is allowed. So how do you represent this? First, we can make her choose the tiffins and say then the water bottle or tiffin box or school bag and then the water bottle. So let me show this. So the level 1, we can make her choose the tiffin box. In level 2, we're looking at, say, school bag. There are only 2 possibilities. So should we add one more? Yes, we should add, right? So that's what the concept tells us to do. We need to add one more layering. Reason being, there are 3 things to choose. As you can see, if we increase the number of things to choose from, the complexity increases. So last one is not exactly how I want it, but okay, let me. So we can see it's not easy to draw this, but yeah, we need to know this. We're going to use it in time. So we have bag done, then the water bottle. So W1, W2. W1, W2. W1, W2. So we are looking at how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So basically 2 into 3 into 2. Right? That would be 12. That's what the fundamental principle of counting tells us. We just have to multiply that. That will be our final answer. So let's write the final answer. Something like this, ending with, say, this. So here in this branch, the kid is choosing tiffin 1, bag 2, and water bottle 1. Right? So that's how you make use of tree diagram. So we can see that we'll end up with the same answer 12 ways. So just by either multiplying or drawing. Where is it used? How it is that we're going to use? We'll be using in this chapter, probability chapter, quite a few places. So anyways, point is, it's going to help and you guys going to write as of now and we'll use it in time and you will appreciate the topic. Just copy one example, that's enough. Do make a note of the following note. It's useful.